11.3, finding inverse trig functions. So we are going to begin with our first step, which is figuring out exactly how to solve for an inverse function. On slide 2, you can see that we have the exact instructions on how to find that inverse function. First step, replace your x with y and replace the y with x. From that point forward, you are going to solve for your new y. Once you have y isolated, you are going to replace that y with the proper notation for an inverse function, which would be f of negative 1 of x. So it would look something like such. Let's take a look at slide 3. In slide 3, we have an actual problem in which we are finding the inverse. So on this left-hand side, we are going to go ahead and find the inverse. And on the right-hand side, we are going to be finding the range of our original equation. And we are going to find the domain and range of our inverse. So let's begin with the left-hand side. We begin with our original equation. Now, our first step is going to be switching the x and y. As you can see, the x comes to the outside as x is equal to 2 sine y minus 1. At this point, we are going to begin moving over our terms over to the left-hand side. So we're going to add 1 to both sides. And then we are going to divide by 2 on both sides. At that point, we now have y on the left-hand side and the remaining part of our equation on the right-hand side. Now, since we have sine y on the left-hand side, we have to get rid of the sine. In order to do that, we are going to multiply by its inverse, which in this case would be the inverse of sine. When you do that, we have y now isolated by itself. And on the right-hand side, we have the inverse sine of x plus 1 over 2. Keep in mind, we are switching the y out with the proper notation, which is f of negative 1 of x is equal to the inverse sine of x plus 1 divided by 2. Now, let's take a look at finding the range of our equation. Now, there are one or two ways that this can be done. First could be algebraically. Generally, I would suggest, if you have already taken pre-calc, you have already studied the parent function of this style equation, I would go ahead, analyze the equation, find your midpoint, and find the range off of its amplitude. So, in this case, we are going to go ahead, we are going to take a look at the equation. In this case, our negative 1 is our midline, and our amplitude is 2. So in this case, what we are going to do is go ahead, mark off our negative 1. We are increasing by 2, which would leave us with 1 as our max, and our min would be negative 3. So our domain in this case, our range in this case would be from negative 3 to positive 1. Now we already have the domain of our equation, which would be right here. Once you have the domain and you have the range, you are able to find the domain and range of the inverse because remember, you would be flipping both of them when going to the inverse. So in this case, the domain of f of negative 1 of x would be equal to the range of the original. The range of the inverse equation would be the domain, which would be from negative pi over 2 to pi over 2. Let's go ahead and take a look at slide 4. In this case, this gives you the opportunity to go ahead, work on this problem. What I highly suggest, pause the movie at this point and work this problem out. By you pausing this video, this will give you the chance to work on it on your own and see whether you're fully understanding this problem or not. So let's go ahead and take a look at the problem. And first, we are going to find the inverse, and then we are going to find all of the range and domains for this problem. Let's go ahead with the inverse. The very first thing that we are going to do is that we are going to switch our x and our y of the equation. So in this case, x is equal to negative 4 sine of 2y minus pi minus 1. First thing we're going to do is add 1 to both sides. X plus 1 is equal to negative 4 sine of 2y minus pi. We're then going to divide by negative 4. So x plus 1 divided by negative 4 is equal to the sine of 2y minus pi. We're going to do the opposite of sine, which would be multiplying by the inverse of sine. This will leave you with inverse sine of x plus 1 over negative 4 is equal to 2y minus pi. Our next step would be to add pi to both sides. So we have inverse sine of x plus 1 over negative 4 plus pi is equal to 2y. And we're then going to divide both sides by 2. Sine inverse of x plus 1 over negative 4 plus pi, all divided by 2 is equal to y. Keep in mind, proper notation is important, and you will have to switch out the y for the f of negative 1 of x. This helps to show that this is the inverse of that original equation. Now, let's go ahead and take a look at the domain and range of our original equation. So off of our original equation, the domain would be from 3 pi over 4 to 5 pi over 4. The range in this case, keep in mind, our midline is negative 1. We are going to increase by 4, which would be 3, and we are going to subtract 4, which would be negative 5. So our range would actually be from negative 5 to 3. when we find the inverse, we are just going to replace their positions. Three pi over 4 and 5 pi over 4. Let's go ahead and take a look at slide 5. In slide 5, we are going to be solving for inverse trig functions. Easiest way to kind of describe exactly what's going on, you are solving for x. In slide 6, if we take a look at this first equation, and remember, we are solving for x. First step we're going to take is dividing both sides by 3. So inverse sine of x is equal to pi over 3. In order to get rid of the inverse sine, we have to multiply by its opposite, which is sine. Here we have x is equal to the sine of pi over 3. Keep in mind, you will have to go ahead and take a look at what the value is. In this case, the sine of pi over 3 is the square root of 3 over 2. Let's go ahead to this next problem. This problem is very similar, in which case we are going to go ahead and we are going to isolate our x. So we have 2 cosine inverse of x is equal to pi over 2. Our very first step is going to be to divide by 2. So cosine inverse of x is equal to pi over 4. We're then going to get rid of our cosine inverse by multiplying by cosine on both sides. That would leave you with x is equal to the cosine of pi over 4. That would leave you with a value of square root of 2 over 2. So, if there are any questions, please feel free to reach out to me at any point.